We're next going to look again at some additional application problems. And these problems, as those we looked at earlier in the module, will require that we solve a quadratic equation, or at least make use of a quadratic function. Now, the first example we're going to consider is the following. We're told that a baseball is thrown upward with an initial velocity of 70 feet per second from a height of 5 feet. Its height is given by the function that you can see highlighted here in blue, which is h is equal to 70t minus 16t squared plus 5. Now, where the h is the height that's measured in feet, and t is the time measured in seconds since the ball was launched. So our first problem to consider is, how high is the ball going to be after 1 second? So I think you would agree with me, all we need to do is to substitute into the equation the value 1 for t. So we'll have h is equal to then 70 times 1 minus 16 times 1 squared plus 5. And in simplifying, we have 70 minus 16 plus 5. And that will then simplify to 59. So we will next write a sentence answering the question that was posed. And so we can state then that after 1 second, the ball has reached a height of 59 feet. Now, the second question we're asked to consider in this situation is, when will the ball be 40 feet high? And so that's really asking us in a different way, after how many seconds from the time the ball is launched will the height of the ball be 40 feet? So for our first step, what we'll do is replace the h in the equation with 40. And then what we need to do then is to solve this resulting equation for t. So let's next put the equation into standard form, and I'm going to make the right side 0 and bring all the terms from right to the left, because I like a quadratic term or second degree term that's positive. So if we do that, we'll have 16 t squared minus 70t plus 35 is equal to 0. Now, I think what will be best is to use the quadratic formula here. This may be factorable, but we don't know that unless we do a lot of experimentation here. But the quadratic formula will give us the solutions right away. So we'll have t then is equal to the opposite of b, so it'd be the opposite of negative 70, plus or minus the square root of b squared, which is negative 70 squared, minus 4 times our a value 16, times our b value then of 35, which is all over 2 times our a value of 16. So now we'll do some simplifying. So the opposite of negative 70 is 70, and plus or minus, and negative 70 squared would be 4,900. If we multiply the 4 times 16 times 35, that'll be 2,240, and the denominator simplifies to 32. So we have then 70 plus or minus the square root of 2,660 then, all over 32. So we'll next get a decimal approximation for the two possible values of t. Now, if we write the two separate expressions for t that we got from the quadratic formula, the first one will be t is equal to 70 minus the square root of 2,660 all divided by 32. And a decimal approximation for that will be 0.58. And for the second expression for t, we have t being equal to 70 plus the square root of 2,660 divided by 32. And the decimal approximation for that is 3.8. Now you might be wondering, gosh, is it really possible to have two different values for t in this particular situation? Now let's take a look at the diagram below here to get an idea just why both of those t values are indeed legitimate. Now remember, we were told that the ball was launched from a height of 5 feet, which you can see is highlighted off here to the left. And let's just say, for the sake of argument, that the path of the ball is what you see in blue. Now the ball is going to rise after it's launched from the height of 5 feet. And we know at a certain point it's going to reach a height of 40 feet. And that will occur for the first time 0.58 seconds after the ball is launched. Now if we continue to look at the blue path, the ball will continue to rise and eventually it will fall back down towards the ground. But there will be another place in the path, which you can see is the second red line here, where the ball will again be 40 feet above the ground. And at that point it will be occurring 3.8 seconds after the ball was launched. So we then can write a sentence answering the question now that we know that both of those values are indeed valid. So we could state then that after 0.58 seconds and 3.8 seconds, the ball will be 40 feet high.